On this lesson of Unit 4B Trig, we are introducing this thing called SOHCAHTOA. So we're going to talk about what this is. Our essential question is, how can I use my calculator to solve trig problems? The first thing I want to bring up is, what are the three ratios we use during trigonometry that you are familiar with? So you should be thinking of O over H, A over H, and O over A. So far we know that this is opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. Now these three ratios, what we have not talked about yet is that they actually have a name. So this ratio is called sine, S-I-N-E. The sine ratio is opposite over hypotenuse. Adjacent over hypotenuse, that is called cosine, C-O-S-I-N-E. And then the very last one, opposite over adjacent, is called tangent, the tangent ratio. Now, you may not have actually heard of these before, but I'm sure you guys have seen all of these. If you're looking at a calculator, you can usually pretty easily find sine, cosine, and tangent on your calculator. So that's where it is on these. It's very easy to find on this type of calculator, sine, cosine, tangent. And then on a graphing calculator, we have sine, cosine, and tangent. And even on your phone calculators. Now on your phone calculators, you do have to turn them sideways. But there's also sine, cosine, and tangent on your phone calculators. So if you look on your phone calculators, we have sine, cosine, and tangent. So we so far have been using our trig table to get all of these ratios. And what I wanted to tell you is that you can actually use your calculator to find that ratio instead. So for example, we've got opposite over hypotenuse. Opposite over hypotenuse is sine. So sine of 2, if I were to type in my calculator sine and then hit 2, close the parentheses, I get 0.034899497. And if we look at sine of 2, 0.0349. Now what they've done is they've rounded, but this number is stored in your calculator. I could do this cosine of 2, and I should get 0.9994, 0.99939, which rounds to 4. So all of these numbers are actually stored in your calculator. Now what this does is this helps out, your calculator helps out in case you have a decimal. So what if I wanted to do the sine of 2.5? That value is in your calculator as well. So we don't have any decimals over here, but that's why the calculator is helpful instead of this trig sheet, because not only does it store all of these numbers that are already here, but it also has decimal values. So that's what we're going to be using today. So sine, cosine, and tangent, but as you could see, they do have abbreviations. So sine, S-I-N, cosine, C-O-S, and tangent, T-A-N. Now one way that you can remember sine, cosine, tangent, that is where this SOHCAHTOA comes in. So we have sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So you could possibly see this written all the way out, SOHCAHTOA, so, S-O-H, ka, that's how you know that's the one with the A, toa, T-O-A. So you could see it written out like this, or sometimes I actually like to write it out like this, S-O-H, so, ka, toa. So either of these works, but this is just an easy way for you to remember which one is sine, which one is cosine, and which one is tangent. And this also kind of helps to figure out how you can stack them on top of each other. Now, to make sure that you are getting the proper answer, you do have to make sure that your calculator is in degree mode. So always you can do that by, I've got my steps over here. So when we're still solving like normal, where we choose our trig ratio, we're going to substitute in our values, and then we're going to solve. But when we're using our calculator, we have to make sure we are in something called degrees. So when we plug in our number, we're saying this is a degree value. So on your calculator, you have to make sure that this says degrees. If not, if we need to change it, we can go to mode. And there's 3 options. It could be in radians. We could be over here, but we want to be in degrees. So I'm going to go over degrees and hit enter. And then once we hit mode, we select degree, we hit enter. Then we are going to exit the screen by hitting second in mode. So we want to quit the screen, so we're going to go to second in mode. So that's how you do it in this calculator. It works the same exact way if you are in a graphing calculator. So in a graphing calculator, we would hit mode. And we are going to, again, we want to make sure that we are on degrees. So we would arrow over, make sure it's not on radians, we want to be on degrees. Make sure you definitely hit enter. And then I'm going to quit up here by hitting second and quit. These calculators are a little tricky. This does not even have a mode button on it. So right up here, so we see degrees, so we're already good on this calculator, but just in case it's on something else, this button right up here, DRG, D stands for degrees. So we want to hit that until we make sure we are on the degrees button. What that does is make sure we have the correct answer spitting out. What we're doing is we're telling the calculator that we are entering in a degree value. Okay, so let me show you one example problem real quick. So it says solve for x. So right here we have a 27.3 degrees. And then this is going to be my opposite side and my adjacent side. So now when we think about this, adjacent and opposite, we need to go back up to the top and say, which one of these are we using? Opposite and adjacent. So we are going to call this tangent. So I'm going to write this down. I'm going to use the abbreviation TAN. I'm going to take the tangent value of 27.3 degrees. And then on my other side, I need to put my opposite over adjacent. My opposite is 13, and my adjacent is x. So all I've done is I've put tangent in my degrees, and then I'm going to put my opposite value and my adjacent value. So we have opposite value and adjacent value. Now this number, what we're going to do is instead of going over and using our chart, and searching for 27 way down here, because I don't have 27.3, instead I can use my calculator to give me that number. So I'm going to type tangent. I'm going to go over here, hit my tangent button, 27.3. And this value is the tangent value for 27.3. So first thing we need to do is put our 1 underneath it, and I'm going to cross multiply. Now you could just plug this number in right now, but watch how I solve this. So I'm going to cross multiply x times tangent 27.3. I'm going to write tangent 27.3 times it by x times x equals 1 times 13 is 13. And then I'm going to get x by itself, so we're going to do inverse operation. I'm going to divide by this tangent 27.3. What you do to one side, we do to the other. Divide by tangent 27.3. So those will cancel, and I get x is about, okay, so let me show you how I would actually type this in the calculator. So what I'm going to do is I'm going to type in 13 divided by tangent 27.3 all in one. So I'm going to do 13 divided by, I'm going to hit tangent 27.3 and close that parentheses. Now when I hit enter, that's going to be my final answer because I have plugged in this entire problem. So when I hit enter, I got 25.187. So it's about 25.187. Okay, go ahead and pause the video and solve this one over here. Your final answer should be approximately 9.439. So what I did was this is if my reference angle is over here, I have opposite and hypotenuse. So opposite and hypotenuse is sine. So I'm using sine of my very long decimal. So sine of 83.9827263 equals, and then my opposite over my hypotenuse. Now, you could, like we've been doing, put your line and put 1 underneath and cross multiply, or think about this as an inverse operations problem. If I thought about this problem, this is very similar to something like 3 equals x over 15. How would we solve this before? If you think about how we used to solve this problem, what's the opposite of dividing by 15? Multiplying by 15. So x equals, in this case, 45. So I did the same process over here. Instead of cross multiplying, what I did was I used inverse operation. So instead of x divided by 15, I got rid of the 15 by multiplying it. And then I did the same thing on the other side. So what you would do in your calculator is I would type in this whole thing, and I've got sine 38.9827263, close my parentheses, you have to do that, times by 15. And that's where I get my 9.436. So you can solve it either way. If you still want to cross multiply, you can. On the back of the page are some word problems. Go ahead and try those and then check back in with me. Okay, so we should have gotten that the tree is about 33.078 feet tall. Now this is important. Word problems need word answers. So I expect that if there's some sort of a word problem, that you are giving at least one complete sentence for your answer. We have an angle of elevation, so that should be 58.4. And it says how tall is the tree, so we want to know the vertical rise on that. And it says that the shadow, remember if you're measuring your shadow is seen on the ground. So that's where my 20.35 is. On the second one, I got that the submarine is about 75.912 feet underwater. So here's my boat, here's my submarine. And then it says it's directly 238 feet away, so I would measure straight to the submarine, 238 feet. The angle of depression, so remember depression is from the horizontal going down. So that's why my 18.6 is right there. And we want to know how deep the underwater is the submarine. So here's my water. So how down below, how deep is the submarine underwater? And I got about 75.912. And again, I did inverse operations on this one just because I think it would be easier to do instead of putting a 1 underneath and cross multiplying it, but that's up to you. Number 3 and number 4 you need to do on your own, and let me know if you have any questions.